Welcome to Hot und Trocken. In our last video, we have studied some basic structures and commands of SQL. In this video, we want to work through some examples where we use the commands to build some SQL queries. Let's recall the syntax and the functionalities of SQL we have discussed so far. All our SQL queries started with select. Select was followed by a select expression, which was either a star symbol, which meant all columns, or some set of selected columns. The select expression could also contain simple mathematical operations based on column names. In our queries, the select expression has always been followed by from, followed by a table name. Select and from are the obligatory parts of the SQL query. Everything what follows now in the edgy brackets is only optional. The optional keyword where is followed by a where condition, which in turn is based on one or more column names. The where condition typically filters or narrows down the result sets which are returned by the query. If we use the optional group by, the results are aggregated to groups according to their values of the column or columns specified in col name, where the resulting groups may, but don't have to, be filtered by using the keyword having along with a condition. Finally, the results returned by the query, be they datasets or groups, may be ordered according to one or more columns in an ascending or descending way. So these are the structural components we already know. Now we want to look at some exercises which play around with exactly these components. Our exercises are based upon one database with only one table, which is called tools. The table tools contains information about different tools in the inventory of a company. Each row represents one type of tool with a name, with the number of this type of tool in the inventory, with the weight of this tool, with the length of this tool, the number of connectors this tool has, and finally the class or category which we can categorize it to. I have loaded this database tools into SQLite Studio, and if we expand this here, you can see that it only contains one table called tools. We can also expand this table and we can see the different columns, which we can also expand. So it has the column ID, name, count, weight, length, connectors, and class. By double-clicking on the column name tools, we can see over here the structure of the table as well as the content of the table. The content is displayed when we click here on the tab Data. So here you get an impression of the first 30 rows or so of the table tools. In this window here, the so-called SQL editor, we can type our SQL queries. Let's check this by typing, for instance, select star from tools, semicolon, and we execute this by clicking here on that little blue arrow symbol. So the result is displayed here in this part of the window. Now let's have a look at our first exercise. It says, list all tools by name which are in class special. And this is how we do it. We start with select. And now we're supposed to select the tools by name. That means we are only interested in the names. So I select the column name. And then from our only table we have, from tools. And now we're supposed to select all tools which are in class special. And if you look here, you see the class and the different values of class, which are special, norm, complex, special. So norm, complex, and special are the only ones I can see here. So we're supposed to select the class with a value special. And now you have to be careful because special is a character string. So we have to compare class with the character string special. So we do this using the where condition. So we say where class is equal to. And now we use the single quotation mark because we have to phrase character strings with quotation marks. So special and closing quotation mark, semicolon, and we execute it. Well, now you see that is the list, hopefully the list of all names of tools which are of class special. But we're not so perfectly happy with this result because we can't verify if we did right, because we can't verify if these all are of class special. So we modify our select statement and add an extra class in here. So we select name and class from tools. And we expect to see an extra column only containing special, showing that we did it right. So let's check that. Yeah, so here we go. Now let's have a look at the second exercise. Which is the heaviest norm tool? Which means, which is the heaviest tool of class norm? Now this one is a little tricky. Because we want to find the heaviest norm tool, that means we maybe want to try something like max weight. Remember, we have this aggregating command which is called max, and we can select max weight, max of weight. If we try that, we can write select max of weight from tools. And because it should be the heaviest norm tool, we want to restrict to the class norm. That means we have to write where class is equal to quotation mark norm quotation mark closed. Select max weight from tools where class equals norm. That looks like a perfectly nice statement, and we execute this. So what do we get? We get a number, max weight, 99.9 something. But the question was, which is the heaviest norm tool? This is only the heaviest weight in class norm, but we don't know anything about the tool. We want at least to know the name, for instance. So now I'm doing something which I already tell you now is actually wrong. But the fallacious thing about this is that it gives the right result in this case. So please stay with me. Now I'm doing this. I'm adding name, an extra name here in the selected columns, and I execute this. So we get again this number 99.9 followed by a name YKD. And I'm telling you now that this solution is not right. And I'm explaining to you this in a second. But the result is the right one. So that is a little confusing here, and you have to think carefully about it. Now, why is this statement not a valid statement? The answer is a little subtle. Let me try to explain it to you. The fact that I'm using max weight means that SQL aggregates all results over the complete table, figuring out the maximum of the weights. And it correctly returns 99.9, which is actually the maximum weight. But the problem here is name. Which name should it choose? Well, we hope and we want it to choose exactly the name of this tool which belongs to the maximum weight. But this is not what we say here. We just say choose a name. We don't say choose that name which belongs to that weight, which is the maximum weight. But probably because SQLite knows that people might do this wrong here, it behaves nicely and gives us what we want, even though that statement is not perfectly valid. Now, of course, there is a right solution using max weight in the right way. But this solution is a little more complicated and uses some aspects of SQL which we don't know yet, so-called nested queries or subqueries. And because I don't want to confuse you with nested queries at this stage, we use a little workaround, a little trick. The idea of this workaround is to simply output all tools of class norm ordered by weight in a descending way. So the first entry in that list should be that tool with the biggest weight. Let's try to do that. So we select, let's simply say we select star from tools. Now we restrict to the class norm, where class equals norm. And now we say order by weight. And because we want to have it descendingly ordered, we have to type DESC. Now let's try to do that one. So here you see that the results are all of class norm, that is right, and that they are descendingly ordered according to weight. And now you see, indeed, that is our biggest weight we found before, so that's perfect. And that indeed is the name YKD we also found with our wrong query. Now to make our workaround solution even a little nicer, I show you this extra command which is called limit, limit limits the result list to the number we specify after limit. So if I type limit 1, it limits the result set to only one row, which gives exactly what we want. Name YKD, and that is the biggest weight of all tools in class norm. Now this exercise was indeed a little tricky, but the next one will give us a break. It's really simple. List all tools longer than 50 ordered by class. Now let's see how that works. We're supposed to list all tools longer than 50 ordered by class. So we start with select. Now because we're supposed to select the tools and no special columns of tools, we simply say select star from tools. Now, which are longer than 50? We can express this using where length is greater than 50. But we're not done yet because we have to order it by class. So we say order by class. Now execute this. Now let's see that it says it has 5,086 rows loaded. Altogether, the table tools contains 10,000 entries, so that's about half of it. And you see that it started with the class complex, and if I scroll down, it's only complex. But that's fine because you see here that it only goes down to row number 1000. But we have the possibility to switch to the next pages here. So let's see if class changes sometimes. Yeah, here we go. So that is page number 3. That's the 2001st entry, and here we are in class norm. And I expect if I switch further, we will find the class special. 5, there we go. Let's have a look at the next one. List the name of all tools which are either longer than 30 and heavier than 70, or which are shorter than 80 and lighter than 100 and not in class special. This one is obviously all about a very complex where condition. Let's try to figure that out step by step. We start with select star from tools. And now how does the where condition look like? All tools which are either longer than 30 and heavier than 70, or which are shorter than 80 and lighter than 100 and not in class special. So let's structure them step by step. Which are either longer than 30 and heavier than 70. Let's figure out this one. I put it in brackets. Longer than 30 means length is greater than 30 and heavier than 70, which is weight greater than 70. Close the brackets. Or which are shorter than 80 and lighter than 100. Shorter than 80 means length shorter than 80 and lighter than 100. Weight smaller than 100. And finally it says and not in class special. So and not in class special means that the class should be unequal to special. So class, now the sign for unequal is smaller greater, and now in quotation marks special. So not in class special. Select star from tools. No, I forgot the most important thing. Where? Where length greater than 30 and weight greater than 70, or length smaller than 80 and weight smaller than 100, and class should be not special. Now check what we get if I do that. Okay, so we see 7,103 rows loaded. Now if we have a closer look, one thing is strange, because here in class we still see some with class special. But didn't we want to exclude the class special? Didn't we want to say every row should be unequal to special? In order to understand this, it's time to speak about the so-called binding strength of logical operators. That is very closely related to what we know from mathematics when we use multiplication and summation. Remember that multiplication of two numbers is always binding stronger than summation. So if I write something like 5 times 3 plus 1, we first evaluate 5 times 3, which is 15, and then we add 1. So the altogether result is this. So if I just rearrange the order here and write 1 plus 5 times 3, that thing is also 16, and it is not 1 plus 5, which is 6, times 3, 18. So it's not 18, right? So the rule is first multiplication, then summation. And there's a similar rule for the logical operators AND and OR. Put in short terms, AND plays the roles of the multiplication and OR plays the role of the summation. The first consequence of this insight is that the brackets I have used here, these as well as these, are not necessary. Why? Because they put AND terms into brackets, but AND is binding stronger than OR anyway. So I could leave away these brackets without changing anything. So we check this. Look here, it's 7,103. If I execute now, it's still 7,103. But we still haven't clarified why there's still data sets with special class. The reason is this AND. Because AND binds stronger than OR, we have these three conditions which are connected by two ANDs, so that without brackets, these three are combined. Then there's the less binding OR, and then we have these two which are also bound by an AND. So without brackets, this AND only belongs and refers to this part and does not affect the part which comes before the OR. So all results which are of class special here must stem from this part of the logical condition. In fact, the text of the exercise said, list the name of all tools which are either longer than 30 and heavier than 70, or smaller than 80 and lighter than 100, and not in class special. Actually, that text is ambiguous and could be understood in a way which perfectly fits to this select statement. In this case, the condition class is unequal to special only belongs to this part of the OR sentence. But if we want to understand the AND class is not equal to special as an overall condition, which should apply to every result, we have to use brackets like this, here and here. That means we want to have this bit, including this OR statement, to first be evaluated, and then additionally this extra condition that class should not be special. Now let's see if something changes if I execute this one. You see, by now we have 7,103. If I execute, well, I get 5,945. Yes, so things changed, and as you see here, there's no special class anymore. To summarize, both of these solutions are right, so the one with these brackets and the one without these brackets. Why is that so? Because the exercise text, the natural language text, is ambiguous, and each of the two interpretations have their variant here. Let's have a look at the next exercise. Calculate the total weight of all tools, count times weight. So the hint in the bracket means that each row contributes by count and by weight to the total weight. So the row with the name X11 says that in the inventory there are 12 tools, each of which has weight 23. So that one row contributes to the total weight by 12 times 23. So over the complete table, for each row, we have to sum up the product's count times weight. So what does this query look like? Now we should select the total weight of all tools, meaning count times weight. So total always means the sum. So we select the sum. Now the sum of what? Well, for each row we said we have to sum up count times weight. So select the sum of count times weight. Now from what? Of course from tools. Without any restriction, without any where statement. Select sum count times weight from tools. That's it. And you see that's a large number. Now let's do the last exercise. Find the maximum weight of tools from each class. This one is very straightforward. We select max of weight from tools. Now we have to group. we have to group by the classes. So we should get for each class value special norm and complex one result. And again, we want to know which one belongs to which class. So we add the class here to the selected columns and execute once more. Now, as a variant of the exercise, we could say that we want to find the maximum weight of tools from each class, but only for those classes which are not the class special. So in order to do that, we have to modify that query by using having. After having, we can write an extra condition we want to impose on the groups which are returned by the query. So we only want to have groups returned which are not of class special. So we can say having class not special and execute. And you see, now we have only the results for the class complex and the class norm. So that's it in this video. Thanks for watching and see you next time.